Well, hello guys and welcome back to Mr. G Physics, the channel that can help you to improve your physical science marks from grade 8 to grade 12. Here is Mr. G, and this time we're going to be making another video for the grade 12. This time we're going to be speaking about dehydrohalogenation. It's another organic reaction. But before we carry on, don't forget to subscribe for the channel so you can get all the notifications and videos we post on regular basis. Now in this case, dehydrohalogenation is an elimination reaction. During elimination reaction, you need to know that you will start in the reactants with one single bond compound that could either be an alkane, it could also be a haloalkane, or could be an alcohol. And these reactions will form an alkene. So it's like the opposite of addition. So this one will form a double bond compound, which in this case is an alkene. Alright, and these are the elimination reaction. Today we're going to focus on the dehydrohalogenation. So in this case, we're going to begin with a haloalkane. And as a product, we are going to have an alkene. Alright, that is the thing. But for this specific reaction, we need some conditions to happen, some very important conditions. Otherwise, this reaction is not going to happen. The first condition is that you need a concentrated solution of a strong base in a pure ethanol as solvent. Okay, so for example, what is a strong base? Which ones are the strong base? Any group 1 element hydroxide is a strong base. For example, it could be NaOH, or it could be KOH, or even LiOH. Those are strong bases. Those are examples of strong bases. This must be a solution of concentrated solution. That is important to have in mind. So for this reaction, we need any of those strong bases, concentrated strong bases. For example, let's write here sodium hydroxide. Okay? Now there is another condition for this reaction to happen. The other condition is that you need heat applied under reflex. Now, what is the meaning of heat under reflex? What is the meaning of under reflex? That means that these gases, remember when you heat in, the gases are going to evaporate, but under reflex means that those gases after the evaporation are going to condensate and return to the reaction. That is the meaning of heat under reflex. Guys, this reaction is almost done, but as a product, you will get another two products. One of them is a compound that depend on the strong base used. This one will be Na, and depend also on the halogen in the haloalkane, and you will also get H2O, which is water. Guys, this is like the general equation for this dehydrohalogenation, but I think we can go and look for one example. It's not that bad. So let's go and look for one example, simple example of dehydrohalogenation. These conditions very important because they are going to ask you in the exam. Those conditions, you have to say that you need a solution of concentrated strong base and you need heat under reflex. Those are the two conditions for this reaction to happen. So let's, without speaking more, go to one simple example. The simple example, we always begin with the simple example, and that is carbon, single bond carbon, and we're going to make here a high haloalkane. In this case, we are going to use, for example, any haloalkane. Let me just move it a little bit down. Carbon and carbon. We're going to have hydrogen. We are going to use here Br. We're going to use here hydrogen. We're going to use here hydrogen. Okay, so this is the haloalkane in this specific reaction. For this reaction to happen, you need strong base. So let's use sodium hydroxide. Okay? So what is going to happen? The hydrohalogen are going to be, or hydrogen halide is going to be eliminated from the reaction. In other words, this bromine is going to go and one of these hydrogen is going to go out of this specific compound. And as a result, an alkene will form. So in the product, what you're going to have? First of all, the alkene. You will have a carbon, double bond carbon, because now the hydrogen and the bromine is gone. So we have left only two hydrogens, and we have only left two hydrogens. Alright, now what is the other compound involved in the product? Sodium. This sodium here is going to break from the OH and is going to get attached to the bromine. So these two are going to get attached and they will form sodium bromide. So this one always will depend on the strong base used as well as the halogen that is in the haloalkane. Is this it? No, the OH will bond with the hydrogen to form H2O. This one is the complete reaction of dehydrohalogenation. Guys, it's quite simple. But now things may get a little bit tricky when you have more than two carbon in the halogen. So let's see one example. We always go to another example. Let's go all the way here and let's use an example of one haloalkane with 4 carbon. And we have this haloalkane. The name of this haloalkane is 2-bromobutane. Now this reaction, remember, you need a concentrated strong base. Do not forget that condition because it's extremely important. Okay, so to this specific reaction we are going to add a concentrated strong base. Any concentrated strong base. We use in the previous one we use NaOH. Let's use for instance KOH. This one will not make any difference. It doesn't matter which one you use. The process is exactly the same. Now what the problem is, here we have two hydrogen that can be eliminated. For sure the bromine is going to be eliminated and as a result you will have potassium bromide. That's not the problem. The problem is that you have two hydrogens that can actually be eliminated. But which one are we going to take off? Which one are we going to take off? And we are going to go to a new rule. Remember Young-Markovnikov. Now we're going to another rule, that is Zaitsev rule. Now Zaitsev rule stays kind of the opposite of Markovnikov. Now Markovnikov, just to recall, Markovnikov said that you are going to take hydrogen. When you're going to give hydrogen, hydrogen is going to go to the carbon that has the more number of hydrogen. Now, Zaitsev rules say that during the elimination, the hydrogen that is going to be eliminated easier is the hydrogen that is connected to the carbon that has less number of hydrogen. So it's like the opposite of Markovnikov. When taking hydrogen away, you are going to take hydrogen always from the carbon that has less number of hydrogen. So saying that, if we look here, this carbon here has only one hydrogen connected to it, but this carbon here, if I can do it here down, this carbon here has 3 hydrogens. Three hydrogens connected to it. So for the major product, we are going to take the hydrogen from the carbon that has a least number of hydrogen. In this case, it's actually 2 hydrogens. Have 2 hydrogens connected. Okay, so we're going to take, to make the major product, the hydrogen from that carbon that has 2 hydrogens. So for the major product, we are going to have carbon, 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 and carbon. Alright, the bromine is for sure gone from the second carbon, and the hydrogen that we are going to take off is the hydrogen from the carbon that is next to the bromine that have least number of hydrogen. So in this case, the double bond is formed here. This carbon will have now only 1 hydrogen here, and now this one will have the hydrogen and this is the major product. This one is the major product, and the name for this major product will be butene. This is the major product. Now, the minor product, you don't have to do it. You always have to do the major product. However, which one would be the minor product? When you take the hydrogen from the carbon that has more hydrogen. Remember, both of them will form during the reaction, but one of them will form more than the other. So the minor product will be now when you take the hydrogen from the carbon with more hydrogen. In this case will be the first carbon, and this one will be the minor product. It will also form, but in less quantities. So this one is, so that is the minor product, but you are not going to do the minor product. You always do the major product. Okay, so this is the reaction. Now, what is missing here? We didn't finish. There are more substances, more product that will be now. If we do it here, because there is no space, so the major product. Let's write here just major product. Major product plus what we have in here. The potassium now will take the Br, so it's going to be K Br plus water. And guys, this is the dehydrohalogenation. It's quite simple. I hope it helped. If it helped, thumb up, subscribe for the channel so you can get all the videos I post on regular basis. And I'll see you next time, Mr. G here.